So next we go to discuss about the MOT, molecular orbital theory is known as a MOT. So in the year of the 1932, Hunds and Mulliken, they proposed this molecular orbital theory. So according to this here, atomic orbitals are combined and it forms the molecular orbitals. For example, here it is one atomic orbital and it is another atomic orbital. So these two atomic orbitals are combined and it forms the molecular orbital. So number of atomic orbitals are equals to number of molecular orbitals, means here two atomic orbitals are involved. So then here it forms the two molecular orbitals, means here the number of atomic orbitals are equals to number of molecular orbitals, and also the energy of atomic orbitals are equals to energy of the molecular orbitals. In these molecular orbitals can be again classified into two types. One is the bonding and another one is the anti-bonding. Okay, molecular orbitals. We see the skeleton diagram of this MOT. It is the skeleton diagram of the MOT diagram. Okay, here these two are the atomic orbitals. Okay, this middle one, it is known as a molecular orbital. So these molecular orbitals are again classified into two. Okay, this one and it is two. Okay, one is known as a bonding orbitals and second one is known as a anti-bonding orbitals. Okay, here these two are the atomic orbitals. These two atomic orbitals are combined and it forms a molecular orbital. So these molecular orbitals are again two types. One is the bonding orbitals and another one is the anti-bonding orbitals. Generally, these bonding orbitals are represented by using sigma and pi. And here this anti-bonding is represented by using star symbol. Sigma star and pi star, it represents the anti-bonding orbitals. So here first that electrons are enters into the bonding. After completely filling of the bonding, then only the remaining electrons are enters into the anti-bonding. Okay, clear? First the electrons are enters into bonding. After completing filling of this bonding, then only the remaining electrons are enters into the anti-bonding. Generally here in this molecular orbitals are expressed by using wave function, that is the psi. This psi, it represents, it explains the amplitude of the electron. It can be derived by using a Schrodinger wave equation. So psi AO, it indicates the atomic orbitals. Okay, it indicates the atomic orbitals. And psi MO means here it indicates the molecular orbitals. Means here it is maybe psi. Molecular orbital is equals to psi atomic orbital plus or minus atomic orbital. Generally here this plus sign, it indicates the bonding orbital. Minus sign, it indicates the anti-bonding orbital. Means psi molecular orbital is equals to psi atomic orbital plus atomic orbital, means it is the bonding. And here it is the psi atomic orbital minus atomic orbital, it indicates the anti-bonding. So now we go to see the embodied diagrams with examples. So here we follow electron filling method. Okay, this molecular orbital is useful to explain the bond order, and magnetic nature. Okay, this embodied diagrams, they explains that particular molecules bond order and magnetic nature. What is the bond order? Bond order means the number of bonds surrounded to that molecule is known as a bond order. Here we see the one example, that is the N2. Here we see the two types of electronic configurations. Okay, first we see that what are the two types of electronic configurations. One is the more than 14 electrons, and next one is the less than 14 electrons. Okay, so first we see here it is atomic orbital and it is the atomic orbital. It is the molecular orbital, means it is sigma, sigma star, otherwise pi, pi star. So now we see the electronic configuration. So first we see the more than 14 electrons. Okay, so more than 14 electrons, in which first we see that electrons are enters into sigma 1s2 and sigma star 1s2, sigma 2s2, sigma star 2s2. See here this pi bond formation, pi 2py, pi 2pz and pi sigma 2px and pi star 2py, pi star 2pz, sigma 2px. Means here more than 14 electrons are there. So first electrons are enters into 1s bonding and anti-bonding, then 2s bonding and anti-bonding of the s orbitals. So next electrons are first enters into the pi 2py. So after filling of that pi 2py, next the remaining electrons are enters into the sigma 2px. So after completing of this bonding, the next electrons are enters into the anti-bonding of the 2py and 2pz, then the remaining electrons are enters into the sigma star 2px. Okay, so here it is less than 14 electrons. Okay, so next option is the less than 14 electrons. So less than 14 electrons means here up to here it is similar. Okay, first it enters into the bonding and anti-bonding of the 1s orbitals and bonding and anti-bonding of the 2s orbitals. So after that next that electron is enters into the sigma 2px. After that next electron is enters into the pi 2py and pi 2pz. Then next electron is enters into the pi star 2py and pi star 2pz. After that enters into the sigma star of the 2px. Okay, so here these two options are there, means more than 14 electrons and less than 14 electrons. Now we see the some examples. So first example is the N2 molecule, means here two nitrogen atoms. It is one nitrogen atom and it is the another nitrogen atom. These two nitrogen atoms are combined and it forms the N2 molecule. Okay, it forms the, so first example is the N2 molecule, means here two nitrogen atoms. It is one nitrogen atom and it is the another nitrogen atom. These two nitrogen atoms are combined and it forms the N2 molecule. So here it is with atomic number 7 and here also it is with 7. Its electronic configuration is 1s2, 2s2, 2p3. It is also 1s2, 2s2, 2p3. Now we take the diagram. 1s2, 2s2, 2p. It is 1, 2, 2s2, 2p3. Okay. So, what is the nitrogen atomic number? 7. Its electronic configuration 1s2, 2s2, 2p3. So, 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So, it is with 2 electrons. Here also 2 electrons. And it is with 3 electrons. And it is with 2 electrons. It is with 2 electrons. And it is with 3 electrons. So, here it is the bonding. These are the atomic orbitals. These are the molecular orbitals. So, these are the atomic orbitals of the 1s orbital. And here it is the molecular orbital. That is the sigma 1s and it is the sigma star 1s. And in the second energy level also, that atomic orbitals are with 2s2, 2s2. So, in that molecular orbital also, it is with the second energy level of the bonding and second energy level of the anti-bonding orbitals. So, here in which atomic orbital total how many electrons are there? 4 electrons are there. Okay. So, first that electrons are enters into the bonding. After filling of the bonding, then remaining electrons are enters into the anti-bonding. So, first from here 1 electron and from here 1 electron it enters into the bonding orbital. So, then here it is the sigma 1s2. So, after that next electrons are enters into anti-bonding 2. It is also sigma star 1s2. In this first energy level, here 2 electrons and here 2 electrons are there. In atomic orbitals, total 4 electrons are there. So, in that molecular orbitals also bonding 2 and anti-bonding 2, total 4 electrons are there. And after first energy level, next second energy level. So, these atomic orbitals in second energy level, it is with first enters into the bonding. So, after that the remaining 2 electrons are enters into the anti-bonding. So, here it is the sigma 2s2 and it is the sigma star 2s2. So, next we go to the 2p3. Okay, in this 2p3 here, it is with one nitrogen atom, here it is with 3 electrons and here another nitrogen is also with 3 electrons. So, it is the less than 14 electrons. Okay. So, first here this 3 plus 3, 6 electrons are enters into the bonding of that molecules. Okay. So, it is the pi sigma 2px, pi 2py and pi 2pz. Okay. So, here total 6 electrons are enters into the bonding 1, 2, 3, 4, 5, 6. So, next this anti-bonding is empty. In that atomic orbitals total how many? 7 plus 7, 14 electrons are there. In that molecular orbital also 14 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, it is a MOT diagram. So, these MOT diagrams are useful to identify the magnetic nature and bond order. So, how to calculate the bond order? What is the definition of the bond order? Bond order means number of bonds present in that molecule is known as a bond order. So, here formula is there, that is the number of bonding electrons minus number of anti-bonding electrons is divided with 2. Okay, that is the formula of the bond order. How many bonding electrons are there? Here, this down one is the bonding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 10. See here. 2, 4, here 6. Total 10 bonding electrons are there. Minus. So, anti-bonding, how many anti-bonding are there? Only first energy level and second energy level of the s orbitals are with anti-bonding orbitals. It is and this one. Okay. So, total how many? 4 divided by 2. 6 by 2 means here bond order is the 3. So here this N2 molecule bond order is 3. So what is bond order? Number of bonds present in a molecule, means here these 2 nitrogen atoms with 3 bonds. 1, 2, 3. So nitrogen's bond order is 3, means in between these 2 nitrogen atoms it is with 3 bonds. So it is the bond order. And next one is the magnetic nature. So here how to identify the magnetic nature? So it is explained based on paired and unpaired electrons. So here any unpaired electrons are there here in this molecular orbitals. So here all these are with paired electrons. So paired electrons means here it shows the diamagnetic in nature. So these unpaired electrons are there, it shows the paramagnetic in nature. So here it is with paired electrons. So here this N2 molecule it shows the diamagnetic in nature. Next we see the another example, O2. So O2 means here 2 oxygen atoms are combined and it forms the O2 molecule. Okay, it is the atomic orbital and here also it is the atomic orbital. Oxygen, its atomic number is 8, its electronic configuration is 1s2, 2s2, 2p4 is the electronic configuration. Now we see the MOT diagram. Its electronic configuration is 1s2, 2s2, 2p4. 1s2, 2s2, p4. 2 electrons. Here also it is the 2 electrons. This with 4 electrons. And here 2 electrons. 2 electrons. 4 electrons. Okay. Here it is the bonding sigma 1s. It is anti-bonding of 1s. It is bonding of 2s. It is anti-bonding of 2s. And here pi 2p by pi 2pz sigma 2px. It is anti-bonding of 2p by anti-bonding of 2pz, and here it is the anti-bonding of 2px. So from this first energy level, first the electrons are enters into the, in this 4 electrons, 2 electrons are enters into the bonding. So after that the remaining 2 electrons are enters into the anti-bonding. So next second energy level, in this 4 atomic orbitals, first that 4 electrons first enters into the bonding and next enters into the anti-bonding. And here total how many are there here? 4 and 4, total 8 electrons are there. Okay. So first here it enters into the here pi 2py. After it completing the fill, next it enters into the sigma 2px. So here how many? Only 6 electrons are there. But here remaining 2 electrons are there. From here 1 and from here 1 is there. So then these are enters into the anti-bonding. Okay, second energy level anti-bonding of the pi star 2py and pi star 2pz. Okay, it is the MOT diagram of the O2 molecule. So here calculate the bond order. Bond order is equals to number of bonding electrons minus number of anti-bonding electrons divided by 2. So here how many bonding electrons are there? It is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2pz2, pi 2py2, sigma 2px2. It is 1, 1. Now we calculate how many bonding electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here 10 minus how many anti-bonding orbitals are there? 1, 2, 3, 4, 5, 6. 6 divided by 2. Means here 4 by 2 means here it is the 2. So here it bond order is 2. Okay, bond order 2 means here that oxygen atom it is surrounded with 2 electrons. Okay, bond order of that O2 molecule is 2. So what is its magnetic nature? In its magnetic nature, see here, it is with 2 unpaired electrons are there. Okay, it is with at least 1 unpaired electron. Okay, then it shows the paramagnetic. Okay, due to the presence of unpaired electron, it shows the paramagnetic nature. It is about the O2 molecule. So O minus 2. So here O minus 2 means generally oxygen it is with 8 plus 8, 16 electrons. Okay. So O minus 2 means here it is with 1 negative charge is there. 1 negative charge means here we add 1. So total 17 electrons are there. So now we see here MOT diagram of the generally oxygen its electron configuration is 1s2, 2s2, 2p4. Here also 1s2, 2s2, 2p4. So here one negative charge is there. One negative charge means here one electron is excess. So here maybe you take any side. Okay, means here in this 2p5 it is one is considered as a 2p5. Now filling of the molecular orbitals. Okay, here it is with 2 electrons. Okay, these 2 electrons means 2 plus 2, 4 electrons. Okay, 4 atomic orbitals are there. So these 4 atomic orbitals are first enters into the bonding of the 1s orbital. So after that the remaining 2 electrons are enters into the anti-bonding of the 1s2. So next 2s, it is with 2 electrons. Here also 2 electrons, total 4. So in which first 2 electrons enters into the bonding of the 2s orbitals. then the remaining 2 electrons are enters into the anti-bonding of the 2s. So then here it is with 1, 2, 3, 4, and another side here it is with 1, 2, 3, 4, 5. So this pi, it is due to the presence of one negative charge. So now we see here in which 4 and here 5, total how many here? 9 electrons are there. So first these are enters into the bonding orbitals. Okay. So here it enters into the bonding, that is the sigma 2py and sigma 2pz and sigma 2px. So here only 6 electrons are enters into the bonding. So the remaining how many electrons are there? Remaining 3 electrons are there. Okay, the 3 electrons are enters into the anti-bonding of the pi star 2py and pi star 2pz. 1, 2, 3. Okay. So now we calculate the bond order. So bond order is equals to number of bonding minus number of anti-bonding orbitals. So how many bonding electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus how many anti-bonding orbitals are there here? 2 plus 2, 4, 5, 6, 7. So 3 by 2. Okay, here its bond order is the 3 by 2. So what is its magnetic nature? Here one unpaired electron is there. Okay, one unpaired electron is there means here it shows the paramagnetic in nature. And here it is with O2 minus 2. Then what happened? O minus 2 means again we add one more electron. So here it is with 2. Okay, so here it is in O2 minus. In case of O minus 2, so here what happened? Its bonding orbitals are 10 and anti-bonding orbitals are 2, 2, 4 and here 4, total 8. So 2 by 2, that is the one is bond order. And what is its magnetic nature? Here in which there is no unpaired electrons. Okay, here all these are the paired electrons. Okay, paired means here it shows the diamagnetic nature.